Hello everyone. So let's see some practice questions from the chapter Chemical Thermodynamics. So let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slide. So we will see today some practice questions from question number 8 to question number 15. Let's start from question number 8. The reversible expansion of an ideal gas under adiabatic and isothermal conditions is shown in the figure. This is the figure. Which of the following statements is incorrect? So we have to choose the incorrect statement. We have given a diagram here showing the isothermal and adiabatic conditions and through which ideal gas is expanding. So at P1, B1 and T1, initial pressure, volume and temperature are, and then P2, V2, T2 and P3, V3, T3 are the final pressure, volume and temperatures for isothermal and adiabatic processes respectively. So options are T1 equals to T2, T3 greater than T1, work done in the isothermal process is greater than work done in the adiabatic process. Change in internal energy is greater than in the isothermal is greater than change in internal energy in the adiabatic process. So you have 10 seconds to solve this question. After that, we will see the answer. Actually, the incorrect statement we have to find out, right? Which will be B option, that is T3 is greater than T1. So how it will be? Okay, so in the A option, we have given T2 is equals to T1. So since change of state, that is from P1, V1, T1 to P2, V2, T2 is isothermal. We can see here P1 to P2, V1 to V2 and T1 to T2 is isothermal. And in the isothermal, change in the temperature is 0. So T1 will become equal to T2, right? So the first statement given in the option A is correct statement. B, since change of state from P1 to P3, P1 to V3 and T1 to T3 is an adiabatic expansion. It brings about cooling of gas, right? Therefore, T3 will be less than T1. Okay. So, which is given in the option B oppositively. That is T3 is greater than T1. So, option B will be the incorrect statement. In option C, work done is given by the area under the curve of the PV diagram. We know that. And as obvious from the given diagram here in the question, magnitude of area under the isothermal one, that is this one, is greater than the work done than that under the adiabatic curve. If we change the color, let's say, so this will be the adiabatic one, area under the curve, right? So we can clearly see that the area under the curve of isothermal is greater than the area under the curve of adiabatic. So the work done for the isothermal process will be greater than work done for the adiabatic, and it is same given in the C option. So it will be correct statement. D is, we know that del E equals to NCV del T. In the isothermal process, del T will become 0, so del E will also become 0. And in adiabatic process, del E equals to NCV T3 minus T1, because in the adiabatic we are going from T1 to T3. So T3 minus T1, and we know that T3 is less than T1, right? That is T3 is less than T1. That means negative term is greater than the positive term. So it will be del E will be negative, right? That is less than 0. So del E of isothermal will be greater than del E of adiabatic. We can see here, because 0 is greater than negative, right? So del E in the isothermal will be greater than del E in the adiabatic. Hence, the option D will be the correct statement. So the correct answer will be B. The only incorrect statement is B option. Okay. Let's move to the next question. Question number 9. A gas present in a cylinder fitted with a frictionless piston expands against a constant pressure of 1 atmosphere from a volume of 2 liter to a volume of 6 liter. In doing so, it absorbs 800 joule heat from surrounding. The increase in internal energy of the process is, so increase in internal energy. We have to find out the increase in internal energy when the constant pressure is 1 atmosphere and volume is changing from 2 to 6 liter. So the options are 305.85 joule, 394.95 joule, 405.83 joule, or minus 463.28 joule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. That is 394.95. So let's see how. Work is done against a constant pressure and thus irreversible. So del V, we can say 6 minus 2, that is 4 liter, and pressure we have given 1 atmosphere. The work done we know is equals to minus P del dV, that is minus 1 multiplied by 4 liter. So it will be minus of 1 into 4 multiplied by 1.987 divided by 0.0821 calorie. So we just change the unit from liter atmosphere to the calorie, and we know that 0.0821 liter atmosphere equals to 1.987 calorie. So this much liter atmosphere will be equal to this much calorie. And on solving this equation, we have W equals to minus 96.81 calorie, and we can convert it in joule. So minus 96.81 multiplied by 4.184 joule, because 1 kilocalorie is 4.4184 joule. So 1 calorie will be 4.184 joule, right? So multiply by this, we have minus 405.04 joule as work, right? And from the first law of thermodynamics, we know that Q equals to del E minus W. Okay. So from this equation, del E, which we have to find out, the increase in internal energy will be equal to Q plus W. That is 800 plus minus of 405.04. And it is coming out as 394.95 joule. So this is the correct answer. This is the correct increase in internal energy after the process. So correct option will be B option. Okay, let's move on to the next question. Question number 10. In an irreversible process taking place at constant T and P, and in which only pressure volume work is being done, the change in Gibbs free energy and change in entropy satisfy the criteria. So we have to find out the change in entropy and the change in Gibbs free energy. Options are that the change in entropy will be negative and change in Gibbs free energy will be negative. Change in entropy is positive, but change in Gibbs free energy is negative. Change in entropy and change in Gibbs free will be equal to, both will be equal to 0, or change in entropy equal to 0, but change in Gibbs free energy should be positive. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. So for an irreversible process to be spontaneous, we know that del S, that is change in entropy, should be positive, any greater than 0, and del G, that is change in Gibbs free energy, should be negative, that is less than 0. So for an spontaneous irreversible process, del G should be negative and del S should be positive, right? So the correct option will be B option. Okay, let's move to the next question. Question number 11. A reaction is non-spontaneous at freezing point of water, but spontaneous at boiling point of water. Then options are del H, change in enthalpy is positive and change in entropy is negative. Change in enthalpy is negative and change in entropy is also negative. Change in enthalpy is negative but change in entropy is positive. Change in enthalpy is positive but change in entropy is negative. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So for spontaneity, we know that Gibbs free energy change should be negative. So according to this equation of Gibbs free energy, which is equals to del H, change in enthalpy, minus T del S. Del H at lower temperature for endothermic process is positive, that's we know. And at lower temperatures, T del S will be less than del H. Because if this will be less, so this will be less, that means this will be negative. So negative will become positive and del H will become positive. Hence, del H will become positive. But at high temperatures, if temperature is so high, TDS will be greater than del H because this will be a positive term, right? So overall term will be T del S and it will be positive term. So and del H minus T del S will become negative because del G will become negative, and hence spontaneous process and del S will be positive in this case, because if T del S will be greater, so del S will be positive, right? Yeah. So let's see the next question. Question number 12. So 1 mole of a liquid at 1 bar and 100 milliliter is taken in an adiabatic container and the pressure is increases steeply to 100 bar. Then at constant pressure of 100 bar, volume decrease by 1 ml. So del U and del H will be respectively. Options are 10 joule and 10 joule, 10 joule and 990 joule, 0 joule or 10 joule, and 980 joule or 10 joule. So you have 10 seconds to solve this question. After that, we will see the answer. So the correct option will be B option. And we know that as the process is carried out under adiabatic conditions, so Q will become 0 and del U will become equal to the W, that is minus P del V. So initially we have P as constant as 100 bar and del V is 99 minus 100 because volume is changing by 1 ml, right? So 100 ml will become 99 ml. So 99 final volume minus initial volume minus 100. So it will be coming out as 100 bar ml. Okay. So for converting it to liter, we have to multiply by 10 to the power minus 3, which is 0.1 bar liter. And in for joule, we can write 0.1 into 100 joule because 1 bar liter equals to 100 joule, right? So del U will become 10 joule. Okay. So for the del H term, H equals to U plus W or U plus PV, right? On differentiating the whole term, we have del H equals to del U plus del of PV, right? And since P is also changing, V is also changing, so we consider both the change here. So del U is 10 joule plus initial pressure will be 100 bar multiplied by final pressure will be 100 bar and final volume will be 99 ml minus initial pressure was 1 bar and initial volume is 100 ml. And on calculating this equation, we have 10 joule plus 9800 bar milliliter, right? So same thing, we convert it into the liter. So 10 joule plus 9.8 bar liter, and which will be equal to 10 joule plus 9.8 multiplied by 100 joule for converting bar liter to joule, and it is coming out as 10 plus 980 joule, which is 990 joule. So del H will become 990 joule. Hence, option B will be the correct answer. Okay. So let's move to the next question. Question number 13. Standard entropy of X2, Y2 and XY3 are 60, 40 and 50 joule Kelvin inverse, mole inverse respectively. For the reaction, half X2 plus 3 by 2 Y2 will give you XY3. Del H change in enthalpy is minus 30 kilojoule. To be at equilibrium, the temperature will be, options are 750 Kelvin, 1000 Kelvin, 1250 Kelvin or 500 Kelvin. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A, that is 750 Kelvin. So we know that the standard entropy change of the reaction is equals to standard entropy change of product minus standard entropy change of reactant, right? Multiply by their coefficient. So standard entropy change for XY3 minus half of standard entropy change for X2 plus 3 by 2 of standard entropy change of Y2. On putting the values given in the question for these, 50 minus half of 60 plus 3 by 2 of 40, we have minus 40 joule Kelvin inverse, mole inverse. And we can calculate the free energy change of reaction, standard free energy change of reaction equals to standard enthalpy change for the reaction minus T standard entropy change of reaction. And we know that in the question it is also given that the equation is at equilibrium. So at equilibrium, del G is 0. So T will become del H naught upon del S naught. And on putting the equation, we have 30 kilojoule given in the question. So in converting into joule, we have 30,000 joule mole inverse divided by 40 joule Kelvin inverse mole inverse. And T will be 750 Kelvin. Hence, option A is the correct answer. Okay, so let's move to the next question. Question number 14. So for an isomerization reaction A to B, the temperature dependence of equilibrium constant is given by log E base Ek equals to 4 minus 2000 divided by T. So we have to find out the value of del S naught at 300 Kelvin. Options are 4R, 5R, 400R or 2000R. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So del G equals to del H minus T del S we know. So and also del G equals to minus 2.303 RT log K. We know both these equations. So we can equate these two equations together. So variation of K with the temperature is given by log K equals to del S naught divided by R because T will cancel out, and del H minus del H naught divided by RT, right? And we have given this equation here in the terms of log K. So on comparing these two equations, we have del S naught divided by R equals to 4, right? Because we can see that del S by R is 4 because positive term is 4. So del S by R is 4. We can say that del S naught is 4R. Hence option A will be the correct answer for this question. Okay, let's move to next question. Question number 15. 1 kg of a block of ice at 0 degrees Celsius is placed into a perfectly insulated sealed container that has 2 kg of water also at 0 degrees Celsius. So both water and ice are at 0 degrees Celsius. Mass is different. Ice is 1 kg and water is 2 kg in the same container. The water and ice completely fill the container, is flexible. After some time, one can expect that. So what we can expect? Given options are, the water will freeze so that the mass of the ice will increase. The ice will melt so that the mass of ice will decrease. Both the amount of water and amount of ice will remain constant, and both the amount of water and amount of ice will decrease. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So the correct answer is option B. So in accordance to second law of thermodynamics, if an irreversible process occurs in a closed system, the entropy of a system always increases. It will always increase, right? It never decrease. And as the ice is more ordered than the water, we know, so that is, ice will have less entropy, but entropy will decrease increase, right? So ice will melt and become water, so that the mass of ice will decrease. Hence option B will be the correct answer for this question. Okay, thank you.